Hello, Professor. Hello, everyone. This is my session for code walkthrough for the UMail database system, which is a graphical database to store unstructured data. And so I'm going to begin with the walkthrough. So I'm going to share my screen and we're going to look at the code and we're going to also touch upon a little bit of demo, but not too much. So here's my system. Here is the server. It's a UMail 2, and I've had many versions of it running prior. So if you look here, I've had 2.5 and I've had UMail 1, which is powered off. So I've kept on iterating and improving my versions, So at one side, we're going to see how the code is executed, and one side, we're going to see the code itself. So here is what I call the UFeeder source. So there are three parts to the code. One is the atomic of factual data, I call factums, and that uses the system is called the cow, which is part of the Neo4j database. And the other part is called is the source, So we have a source like a book, chapter, paragraph, and then a line, So how we put all that sources is as part of UFeeder source. So we're feeding the source also, and the source should be able to say, okay, this line comes from chapter 7 and verse 4, or it can be if it can be section 2.3 of a book of code law book, So that precision of writing the source is that program is called UFeeder underscore source. So that's how we write the data in, and I will show you how it's being executed. So let's exit out. And there's another program called the cow, which holds the factomic data, so that's the end result. So here's the UFeeder source. So all I'm going to say is I'm going to show what the code, the executable here. So I'm going to say source.py, and it's going to show UFeeder source. So I've created a source called S1, which is going to feed the Bible in, so it feeds it from a textbook and will show how this unstructured data is stored, but also how the source is stored, And at the same time, I'm going to show, wait, my Neo4j example, the database itself. So I will show that as well to show you how the data is inserted. And then we can see both at the same time, And let's minimize this. Okay, so here, if we say what is S1, so this will show S1 is a source. It has this attribute. It has the subcontext. So we just have to look at the last line. S1 is a source. It has a subcontext testament. It has a subcontext book, which has a subcontext chapter, which is subcontext verse. So it has got a whole generation of a subcontext under it, which is very important. Let's say you have we have the programming language Python. So it will say Python P1 has a subcontext version, and version has a type 2, version 3, version 4. So you can give the whole subcontext of a programming language by writing this. And let's say you have a movie. S1 is a movie. S1 has a subcontext word, So the whole line of a movie is just one word without any, which is written hexadecimal probably, which is the movie running, So that's how we explain a context of the data, right? So, but we can also use it to say describe S1, and it'll also give you the same thing. Describe. Perfect. So that it is also described Bible is a book, which is a verb, which is a noun, which is a subtype of word. So we're describing the whole subcontext of the data in one shot, And then let's execute. So now let us see a bit of code first, So I have two Python classes, and they're inside these two programs. So so I have these programs that are written, and I've had several versions. So first I'm going to say ufeeder.py. So if I go here, this is the one that's going to insert data, but this will insert the facts of data. So this is word link. So this part is very important, because when it creates a node and a relationship, it first must check whether that node is already there, because it shouldn't build another node if the node is there. Otherwise, that will defeat our whole purpose of graphical databases, that each word is repeated only once in the whole database. So first it checks, and in this part, if it's not there, it's going to create the node. And then here it runs through two if loops, if conditions. If the second node is not there, then it's going to create the second node. And finally, it creates a relationship. This is the relationship that's created. And then it adds a label also. And if that node is not there, it's going to create that node, And here, the node in this section, the node is already present. So there's no requirement to create it. All it's going to do is it's going to add the relationship. So these 4 checks, if it's not there, would confuse the whole system. Remember, everything is so fragile in a graphical database. And if we mess up the relationships, it's purposeless, So it's very precision programming, precision insertion here. And we have another relation called is-a. So it goes with the name, and is a new, and is a subtype of, and is a synonym of, and is a part of, and is a generic relationship. So you can create a generic relationship here with any relationship. And then finally, it has a new count of, has attributes, count, show synonyms, open file, describe. Describe is very complex, because you want to describe a node. First, it goes around every relationship that has a relationship name is a subtype of, or is a. It collects all the data in here, and then it loops around the arrays, and then it prints it off, which is how you get an explanation for each object, And here again, it matches with this one shows the attributes it has, so it matches with the attributes. As you can see, there's no select statement. Everything is just match and return and process data. It's cipher.execute. So you will find it extremely unconventional, but it's very useful. Then you have the UFeeder program that actually splits the data, and I'm going to just show the comments, because the comments also are very important, and we can modify this to get different data sets and to get different input strings, And here's in words, and here's delete relationship ID has open. So this is how the data comes in from the input that we see in the UFeeder source, and then this executes functions here, which are then executed. Yes, and then now is the UFeeder underscore source, and this one has how the data is acquired, how the source is acquired. So this is also looks similar, except that the processing is a bit different. I will show you only the bottom, because it uses very few functions. So this is how it reads the data, and it puts it into 4 different subcontexts: testament, book, chapter, verse, TBCV, or you can change the order. And we are going to add 2 subcontexts, line and alphabet. So it's going to categorize every line and every alphabet also using this input string, and then it's going to process all these words, and then it's going to store it in the graphical database. So this is one aspect. And now after that, so this is how we input data, and then we have the cow. So if we put tc.py, this stores the factomic data. So in this, I can just write factual data like Adam is a man. See, it created a node called Adam is a man. And then what else do we say? What Abraham or Eve, yeah. So Eve is a woman. See, it created this node also, so those two nodes, and so we have that. And then we have the actual display of the nodes. And so that's going to be in the graphical database. So this is how it is. And we have all these HTML and particles and incremental. And if I go into one of that, umail to .html, let's share this out. So this one, in this code, it executes a match statement from the database, and it returns it, and then it displays that in nodes and edges. So this is extremely complex, So this is the actual display of it. So that's the three parts, and so here's the code part, one for the actual factual database and one for the actual source, the Studfeeder source. So two ways of putting in data. And the third one is the actual display of the graphical database, So with that, my 10 minutes are up. Thank you very much.